Okay, so the mean number of faculty is 138.571429, and since we let X be faculty, that's X bar, okay? Then the next number that they give us is the 43.649579. What is that?
That's the standard deviation of X.
Okay, it's the standard deviation of X. Okay, because it says the mean number of faculty is 138.5 blah 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 with a standard deviation of 43.64. So that's standard deviation of X. Okay, so I just put a little X down there so I know that it's the population standard deviation for the X's. So that's 43.649579. Okay, then no, keep all the numbers until the final answer, because then you're going to get rounding error if you don't. Okay, what's the next number that they give us? Okay, the mean of Y, the 1,384.142857. Okay, so that's the mean of Y. So how do I write that? What symbol do I use? Y bar. So Y bar equals 1,384.142857. Okay, and then the next number is the standard deviation of Y, because it says the number of students, which we called Y, has a mean of 1,384 and a standard deviation of 319. So it's going to be sigma with a lowercase y there. Okay, so the standard deviation of Y is 319.522784. Okay, so it says fill in the missing blanks and calculate the correlation coefficient. Okay, so if you look at the formula here, this is the formula for correlation coefficient. And this chart is already built to help us use that formula. Okay, so this is telling me to take each X value, subtract the mean of the X from it, and then take that answer and divide by the standard deviation of X. Make sense? And then do the same thing for the Y's, and then multiply them together. And then after we multiply them together, then we're going to add them all up. Okay, so that's the last thing you do after you do everything that follows that sum sign. Okay, so this summation means add together everything that's after it. Okay, so this chart helps me to do that formula. You can see it's giving me the first column is this xi minus x bar over s of x. And S of X is the standard sample standard deviation, which this is a sample. It tells me a random selection, so it is a sample. So these actually should be S's, not sigmas. So that should be S, lowercase s of X, and lowercase s of Y. Sorry about that. S of X and S of Y. Okay, so in order to get, so let's just try one of the ones that's already in there for us, just to make sure that we understand what the formula is saying here. Okay, so this is saying take the X value, subtract the mean from it, take that answer and divide by the standard deviation for X. Okay, so let's start with 99. Okay, so take 99. 99, and then we're going to subtract from that the mean of the x's, which is 138.571429. And go ahead and press enter to get that answer, okay? Because it's saying get that answer and then divide by the standard deviation of x. Okay, so the standard deviation of x is that 43.649579. So since we already have that answer in there, we can just put divided by 43.649579 and then enter. So we get negative 0.906571 if it's rounded to 6 decimal places, okay? So that's how they came up with that number. Now we need to fill in these blanks. There's a couple of them here. Okay, so you can use the numbers that are already in there just to check and make sure that you're understanding the way that the formula is written. Okay? All right, so here we go. Put in 110 minus the mean, and let me go ahead and show you too, you can put in open parentheses, put in the whole thing at once, just like this. So open parentheses, then put in 110 minus the mean of the x, so 138.571429, then close parentheses, then divided by the standard deviation, 43.649579, and then enter. So that value is going to be negative 0.654564 if we round it to 6 places just like they did. Okay? So 654564. Any questions on that? Okay, so leave that in your calculator and push second entry, and it's going to pull up what you just put in. But now you can go in and you can change the x value from 110 to 138 using your arrows. So just go over to where the arrow over to the 110 and put in the 138 and then enter, and it'll give you the next one. So that'll save you some time of having to type it all in again, okay? All right, so that one here is going to be negative 0.013091. Okay? Everybody see the rounding there? If I want to round it to 6 places, 1, 2, 3, 4, 5, 6, the 1 is the 6th place. So then look at the one after it, it's a 2. So since it's not 5 or more, we leave that one alone and just chop it off there. Okay? Any questions on that? Okay. So then the next column, we do the same thing with the y values. Okay, so you take each y value, subtract the mean of the y's from it, and then divide by the standard deviation. Any questions on that? Okay, so everyone do those 2 blanks, and then we'll check the answers. Okay? So remember, this time you're putting in the y value, not the x value. Okay, so you're putting in that 1,290 minus the mean of the y's, not the x's. Okay, did anybody get that first one yet?
Yes.
What'd you get?
Negative 0.90657.
Okay, let's see. All right, so did you put in open parentheses?
And I did it separately.
Huh? You did it separately? Okay, but you did 1,290 minus the mean is 1,384.142857, and then divided by 319.522784. Okay, so I got negative 0.2946358. So 636. Good. Okay. Is that what everybody else got? Did you get that now? Okay. Any questions on how to do that? So you're taking the y value from the column here, the 1,209 or 1,290, and then subtracting from it the mean of the y's, and then taking that and dividing it by the standard deviation. So if you put it just the way they have it in that top column up there with parentheses around the y minus y bar, and then divided by the standard deviation, then you can do second entry, the bottom corner, and then you can just go in and change, use your arrow key and go in and change the 1290 to 1283. And then press enter. You don't even have to go to the end of it to press enter, just press enter. Okay, so what did you get on that one?
Negative 0.316543.
Good. Okay, so negative 0.316543. All right, any questions on that? Okay, so this last column over here, if you look at the formula sheet, remember this is what you're going to have for the test, so that's why I keep referring back to that. If you look at the formula sheet, we're taking that first column that we did and multiplying it by the second column that we did. Okay, that's what this is doing over here. So you're going to multiply this negative 0.654564 times negative 0.294636 to get the answer for this column. Okay? So negative point, and make sure negative is the one down at the bottom, not the minus sign over at the side. So negative 0.654564 times negative 0.294636. Okay, so I got 0.192858. Is that what you got? Yes? Any problems with that? Any questions on that? Okay, so we have one more to fill in down here. Okay, so this is multiplying together the 1.8655064 and 2.16. So multiply those two together to get this answer over here. Okay, so 1.8655064 times 2.16 162,153. Enter. So 4.033510. Any questions on that? Okay, so notice this last column here is the sum of that column. Okay, so if you look at our formula, you took what we did with the x's times what we did with the y's, and then you take the column where you multiplied them together and you add up that column. That's going to be that numerator there. Okay? Any questions on that? Everybody clear on that? Okay. All right. So once we have that, then to find R, all we have to do is take that value, 4.872249, and divide by n minus 1. So what is n? So we have 1, 2, 3, 4, 5, 6, 7, right? So n equals 7. So it's going to be that number divided by 7 minus 1. Okay? So R is going to be 4.872249 divided by 7 minus 1 is 6. So R equals 0.81204. So 1, 2, 3, 4, 5, 6 is the 1. So since it's followed by a 5, we're going to increase that 1 to a 2. Okay? Any questions on that about how to find the R? Okay, so we know also how to do that with our calculator, so let's double check that answer with our calculator. Okay, so you're going to take all of your x values and put it in list 1, all of your y values and put it in list 2. So do stat, edit is already highlighted, so enter that. If you have something in your list 1, go ahead and arrow up to highlight L1, and then clear, and then arrow back down, and it'll clear all that out. Same thing with L2, put your cursor on L2, and then press clear, and then arrow back down, and it'll clear that out. Okay? So in L1, we're going to put 99, 110, 113, 116, 138, 174, and 220. Okay? Then in L2, we're going to put 1,353, 1,290, enter, 1,091, enter, 1,213, enter, 1,384, enter, 1,283, enter, and 2,075, enter. Okay? Everybody got them in? Okay, so then to find the R, you're going to do stat, go over to calc, and then down to number 4, linreg AX plus B, and enter. Make sure your X list is L1. So L1 you put in by second and the number 1 key. And then your Y list should be L2. Your frequency list can stay blank because we're counting each value that we have in our list as 1. So we don't have to change that. And then go ahead and calculate. Okay? So if it doesn't give you R squared and R, remember there's one time you have to change on your calculator. You do second catalog, and then go down to diagnostic on. It's in alphabetical order, so if you just go down to the D's, scroll down with your arrow key. So if for some reason your calculator is reset or something, you'd have to do this one time. So enter again, and with diagnostic on in there, and that says done. And then you do again stat calc number 4, len reg ax plus b, list 1 for the x's, list 2 for the y's, and calculate. Okay, so that gives me the r squared, the a, and the b. Okay, so the r is the 0.812042. Okay, so it's the same thing as we got using this table. All right? Any questions on how to find r? Okay, it says then also find the linear regression equation. Okay, so the linear regression equation, if you look at your formula sheet, it says y hat equals b naught plus b1x. Okay, so b1x, here's a formula that you can use to find it. Okay, and so in order to use that formula, you would have to multiply together all of the x's and the y's. So you would take this column and multiply it together, and then you would add them up. Okay, and this column, the sum of the x's, would be all of the x values added up. Then this number, the sum of the y's, would be all of the y's added up. Okay, then you would have to square each x value. So 99 times 99, 110 times 110, and then you would add all those squares together to get this number. And then the n is just the number that we have in our sample, and then the sum of the x's is going to be the total of that column. So you would take that total and square it and put it here. So that total times itself right there. Okay, so that's how you would use those formulas. We just found it with our calculator. So in our calculator, notice it says y equals ax plus b. Okay, so this is from the calculator. This is from your formula sheet. Okay, so the one next to the x, the one that's multiplied by the x, is the slope. Okay, so in this case, the slope is b1, b sub 1. Okay, over here, the slope is a. So if it asks you to find the slope, what you're looking for is the one that's next to the a, or next to the x. Okay? So what is the slope that we were given? 5.944290032. Good. Okay. All right. So then the other one that's not next to the x, what is that? It's the y-intercept, right? Okay, so in this formula, the b stands for the y-intercept. In this formula, which one is the y-intercept? B naught. Okay. All right, so what did we get for the y-intercept then here? 560.4340556. Okay, so we need to interpret these things that we found. So the R, that is the linear correlation coefficient, right? So we need to see if that is significant or not. And so remember, we used the table 2, in order to check that out. So in our problem, n is 7. So go down the table to 7, and what's the critical value? 0.754. Okay? So we need to compare the absolute value of our R to our critical value. Okay? So how do those two compare? So what's the absolute value of 0.812042? If you take the absolute value, it just makes it positive, right? So it's the same. Okay? So that means the R, absolute value of R, is 0.812042. Okay? The critical value we looked up on the table for 7 is 0.754. So if the absolute value of the R is greater than the critical value, that means there is a linear relationship between the x values and the y values. So the x values are the faculty, between the number of faculty and the number of students. Okay, so is that linear relationship positive or negative? Positive, because the R was positive to begin with. If it was negative to begin with, then we would say there's a negative linear relationship. So we're going to say there is a positive linear relationship between the number of faculty and the number of students. Okay? So that means as the number of faculty gets higher, the number of students also gets higher. Okay? As the number of faculty gets lower, the number of students also gets lower. Does that make sense? Okay. So let's also talk about the slope and y-intercept and what they mean. Okay? So, so that slope, what that means, so this is, if it asks you to interpret the slope, you say for every increase of 1 unit of the x value. So the unit of the x value is faculty, right? So it can't be a half of a faculty or anything. So it's an increase of 1 unit of the x value, so of faculties. So every increase of 1 faculty. So every time we add 1 faculty member, there is an increase. Because the slope is positive, it's an increase. If the slope is negative, it's a decrease. So there is an increase. I'm going to go ahead and put in parentheses decrease, just because that could change. Okay, this always stays positive. That It's always an increase in the x value. This is of one x value. Okay, so for every increase of one x value, there is an increase or decrease, and that depends on whether the slope is positive or negative. Okay, so in this case, it's an increase of 5.9442903 students. And of course, you can't have 5.9 students, so I think I would just put in there 6 students. Okay, so for every increase of one faculty, there's an increase of 6 students. Does that make sense? So that's how you interpret the slope. So the y-intercept, that's the value of y when x equals 0. Okay? So sometimes that makes sense for a word problem, and sometimes it doesn't. So in this case, does it make sense that as we increase, if x, the number of faculty, equals 0, that there would be 560 students? No. If there's no faculty, then the students aren't going to come because there's nobody to teach them, right? So we would say the y-intercept does not have any meaning. In this problem. Also, if you look at your x values, is there an x, anything, does x equal 0 fit in here? What's the lowest value we have? 99. What's the highest? 220. So 0 is outside of the scope of this model as well. Okay, so you could say that 0, x equals 0 is outside of the scope of this model. And that's because we only have x values between 99 and 220. Okay? All right, so since I said there is a linear relationship, then I can use the formula that I would get with that slope and intercept as a prediction equation. So the formula, it said to find the linear regression equation. So let's go ahead and plug these values into that formula. So it's going to be y equals the slope, which is 5.944290. We'll just put that, x, and then plus the b value, or the y-intercept, which is 560.434,056. Okay, so this is the regression equation. And I put a little hat on it because that shows that this is a prediction value. So I can pick any x value that is in between 99 and 220. Okay? So I could pick 125 and say, okay, let's predict if I have 125 faculty, how many students would I have? Okay? So let's try that. So I'm adding to the problem a little bit. if we have 125 faculty, how many students would you expect? Okay, so use that formula. So y is the number of students equals 5.944290 times 125 for x, 125 faculty, plus 560.434056. Okay, so what does that equal? 1,303.
Yes.
Point what? 470306. Okay, so of course we can't have 0.47 students, so we could just say 1,303 students. Okay? Any questions on that problem? Everybody feel like you could do that? Okay, so like I said, print this out again and try that on your own. Okay, so disjoint and mutually exclusive events. Identify if the events are disjoint or mutually exclusive. So remember, disjoint or mutually exclusive means that two events cannot happen at the same time. Okay? So here are go ahead and underline the two different events just to identify them. So one of them is roll 2 dice. That's one of the events. And and get a sum of 7. Okay? So actually rolling the 2 die is the experiment. The events are get a sum of 7 or get doubles. Okay, so those are the two possible events. Can those happen at the same time?
No.
No, because there are no doubles that would equal 7, right? So 3 and 3 would give me 6. 4 and 4 would give me 8. There's no 3.5 on the die. So you can't get a sum of 7 and a double at the same time. Make sense? Okay, so this one we would say this one is mutually exclusive or disjoint. Okay, what about the next one? A student is a sophomore and the student is a business major. So one of the events is the student is a sophomore. The other one is the student is a business major. Can those both happen at the same time?
Yes.
Yes. Okay, so this is not disjoint or mutually exclusive. Okay. Results from 2 track horses, both the mile. Okay, so the result, can we get the exact same result from 2 track horses if they're both running a mile? Yes,
Yeah.
that could happen. Probably not exactly, but it could happen. Okay, so we're saying that that is also not disjoint or mutually exclusive. Okay? All right, classic probability. The number of desired outcomes divided by the total number of outcomes. Okay, given the word supercalifragilistic, expialidocious, right? Okay, so what is the probability that if you select a letter at random, you will get an I?
4 out of 20.
Okay, so how many I's are there?
4.
4. Okay, so there are 4. And how many letters total are there? 20. Okay, so 4 out of 20,
0.2.
0.2. Okay, so the probability of getting an I is 0.2. Okay, so remember, if it asks you to find a probability, your answer has to be between 0 and 1, right? All probabilities are between 0 and 1. And then if you add together the probabilities of all possible outcomes, it should add up to 1. So for example, in supercalifragilistic, if I do the probability of getting an S, a U, a P, an E, an R, each letter, if I do the probability of every one of them, and then add all those probabilities together, what should it equal? 1. Okay, because those are all the possible outcomes for this problem. All right, so those are the two big rules for probability distributions. All right, so here's a table for pre-made gift baskets. Okay, so these are items that are in the gift baskets: cookies, mugs, candy, coffee, and tea. Okay, so find the probability of either coffee or candy in a gift basket. Okay, so because of the word or, what are we going to do? Add. Okay, so that's telling me I'm going to add. Okay, so what's the probability of coffee being in a gift basket? So,
1, 2, 5, 9.
so the probability of coffee plus the probability of candy. Can you have coffee and candy in the same basket?
Yes.
Yes. Okay, so we need to subtract out the probability of coffee and candy because those are not mutually exclusive, right? They can both be in the same basket. Okay, so what's the probability of coffee?
0, 1, 2, 5,
Give me the fraction first.
20, 77.
So coffee is this whole row, right? So it gives you the total over here. So how many? 43 out of how many? 77. So 43 out of 77 baskets have coffee in them. Okay, what about the probability of candy?
22 out of 77.
Okay, so candy is this whole column. They gave me the total already, so that's 22 out of 77. And then I have to subtract out the baskets that have coffee and candy because I added them in this row and in that column. So what did I add twice there? 10 out of 77.
So if they're not disjoint, you're going to subtract?
Yes, that's correct. If they are disjoint, then that equals 0. Okay? So if you look at your formula sheet, here's the addition rule. Okay? Probability of E plus the probability of F minus the probability of E and F. So if they're disjoint, that probability of E and F is going to be 0. Okay? All right, so 43, now since they have a common denominator, the answer will have the same denominator, and we just go ahead and add and subtract across the top. So 43 plus 22 minus 10. Okay, so 43 plus 22 minus 10. It's 55 over 77. Okay, and you can go ahead and divide that out. So 0.714286. Okay? So you can either answer as a decimal or as a reduced fraction. That's not reduced. What goes into both of those? 11, right? So 55 divided by 11 is 5, and 77 divided by 11 is 7. Okay, so this would be your reduced answer. So you could either have this answer or this answer. Okay? Any questions on that? Okay. Find the probability of getting T given, this is the important word here, given the gift basket contains a mug. Okay, so since we're only looking at the gift baskets that contain mugs because we were given that it contains a mug, that means we're only looking at this column. Okay, so only that column. So our new total is 23. Okay? So out of that column, what is the probability of getting T? 10. So that's why it's 10 out of 23. So 0.43478 Okay, any questions on that? So when it says given, that means you're only looking at that column or that row, and whatever the total of that is your new total for the probability. Okay, because you're not considering anything else. All right, find the probability that a gift basket will contain tea and cookies. So what does the and mean? Multiply. Okay, so we want the probability of tea times the probability of cookies. So what's the probability of tea? $34 out of 77 times the probability of cookies. How many baskets have cookies? 32 out of 77. Okay, so this is assuming that they're independent. Okay, so what we have here is the probability of tea and cookies, right? So look at this formula, probability of tea and cookies. Okay, so the probability of tea is that 34. So probability of tea times the probability of cookies given that we have tea. Okay? So the probability of tea times the probability of cookies given that we have tea. So this one, given that we have tea, what is the row of tea? What's our new total? 34. And then how many out of that row of tea, how many have cookies in it? 12. Okay, so using that formula for probability of E and F, okay, the probability of E is the T, and F is the cookies. So probability of cookies given T is this 12 over 34. Okay, so the 34s divide out, and that leaves you with 12 out of 77. Okay? So the other way to look at that is if you look at the probability of T and cookies, right here is T, here's cookies. So only this 12 is both, right? So just where that row and that column cross is the and part. Okay, so T and cookies is 12 out of a total of 77. So that's the other way to look at that.
I'm very confused on how would we know what formula to use? Because there's no way I would have known what formula to use on that one.
So this says T and cookies. So if you come to the multiplication rule, it's E and F. So that's how I would have known that it was that one. Okay. If you're given a two-way table like this, the and part is going to be where the row and column intersect. Okay, out of the total of the whole table. Okay, so for instance, if I wanted to do the probability of coffee and candy, then what would it be? 10 out of 77. Okay, the probability of tea and mugs, 10 out of 77. Okay, does that make sense? All right, so 12 out of 77 is 0.1558. For I guess we're doing them to 6 places on here, so. Okay. So if you use that formula, the numerator and denominator are going to cancel out and give you that, but if you have a two-way table, you don't even have to use the formula. You can just find where the column and row cross divided by the total of the whole table. Okay? All right, find the probability that a gift basket does not include tea.
43 over 77.
Okay, so does not include tea. So how many of the gift baskets do include tea?
34.
Okay, so 34 out of the 77 do include tea, right? So the probability of not tea is 1 minus the probability of tea. Okay, so 1 minus the probability of tea is 34 out of 77. So 1 can be written as anything over itself, right? So I need a common denominator here. So I'm going to make that 77 over 77 minus 34 out of 77. So 77 minus 34 equals 43 out of 77. Okay. So 43 divided by 77 equals 0.558. And you can, again, use the reduced fraction or the decimal. So you can use the 43 over 77 or 0.5588442. Okay, so part E has 20 over 32. So what is that?
Cookies and coffee over.
So the total 32 is the number of cookies, right? So that is given cookies. Okay? So what is that 20 then? If we're only looking at the cookies column, it's
Coffee.
coffee. So the probability that you have coffee given that you have cookies. Make sense? Any questions on that? Okay. So 3 out of 4 American adults under age 35, number 7 here on the review, 3 out of 4 American adults under age 35 have eaten pizza for breakfast. If a random sample of 10 adults under age 35 is selected, find the probability that exactly 7 have eaten pizza for breakfast. Okay?
7 out of 10.
Okay, so don't look at A yet, just look at this top up here. So 3 out of 4 Americans have eaten pizza for breakfast. So what does that 3 out of 4 tell me?
75%.
Okay, so that's the probability of eating pizza for breakfast, right? So the probability of eating pizza for breakfast is 3 out of 4 or 0.75. Okay? If a random sample of 10 adults under age 35 is selected, so what is the 10? Sample size. So that's my N, right? Okay, so what is the probability that exactly 7 have eaten pizza for breakfast?
So 7 over 10.
Okay, so this is, so really what your probability exactly 7 have eaten pizza. Right? So that means the probability that the one ate pizza, the first one ate pizza, times the probability that the second one ate pizza. Right? Because it's the first one ate pizza and the second one and the third one and the fourth one and the fifth one all the way up to 7. Okay? So 1, 2, 3. So how many of those are we going to have? 7. Okay, so probability 8 pizza. Okay, what about the other 3? So there's going to be 7 of these. So what about the other 3? Because there's 10 total. They did not eat pizza, right? So we're going to have times probability no pizza times probability no pizza times probability no pizza, right? Okay, so what's the probability then of not eating pizza for breakfast? What is it?
3 out of 10.
Okay, so eating pizza for breakfast is 3 out of 4. So not eating pizza for breakfast is how many out of 4? 1 out of 4. Or 0.25. Okay, so even before you look at part A, you can figure out the probability of eating pizza for breakfast and not eating pizza for breakfast. Make sense?
No.
So it says 3 out of 4 American adults have eaten pizza for breakfast. Okay, so that gives me the probability, so 75% that a person has eaten pizza for breakfast. So not having eaten pizza for breakfast is the complement of that. So it's 1 minus that, right?
Yes.
Okay. All right, so we're going to have, how many ate pizza then?
7.
7. So 0.75 to the what power? 7th power, because there are 7 of those, right? And then the probability that 3 of them did not eat pizza. So that's a 0.25, and that's 3 of them. Does that make sense? Okay, so 0.75, and then the caret key is above the division key to the 7th power, and then do the right arrow to get out of the exponent, and then put times 0.25, and then the caret key to the 3rd power, and then push the right arrow key to get out of the exponent and enter. So 0.002085, that's going to be 86, right? 1, 2, 3, 4, 5. It's followed by a 6, so that's going to move that up to a 6. Okay.